Hello everyone, welcome back to another GIS Mathematics lecture video. And in this lecture video I want to walk through two examples of scalar multiplication, and I want to show you scalar division and show you how they're the same thing. So what we've got in this particular instance is we have a scalar that we've called x and we've set it equal to 3, and we have a matrix that we've called A, which is a 3 by 2 matrix, right? 3 rows, 2 columns. The numbers in here are, I just picked them at random. And we're asking ourselves, what is x times a? Right? This is how you would symbolize scalar multiplication. So what I do is we're going to rewrite down our x, and I'm going to color code things so we can keep track of stuff. 3, right, that's our scalar, times our matrix, which we have 1, 3, 7, 5, 4, and 6. Right? So what does this equal? Well, again, we have to realize that scalar multiplication does not change the dimensions. So we have a 3 by 2 input. We're going to have a 3 by 2 output. I'm going to give myself plenty of room here to write down our numbers. So again, I copy down what we have in A. So just a little more room. Since we're multiplying, I put the little dot here just to keep track of what we're doing, right? To keep track of the fact that we're multiplying. And then we're going to write down our scalar in every position. So then we transfer that over. 1 times 3 is 3. 3 times 3 is 9. 7 times 3 is 21. 5 times 3 is 15. 4 times 3 is 12. And 6 times 3 is 18. Right? So this right here is the scalar multiplication of 3 times the matrix A. Again, we just multiply each element in the matrix by the scalar. Okay? So let's look at what does it mean to divide, right? A over x. So we're going to rely on this idea of dividing is the same thing as multiplying by the inverse, okay? So the inverse of 3 is 1/3. So let's do this, right? A divided by x, again in this case x is supposed to be lowercase, is the same thing as saying 1 over x times a. Right, this is the same as multiplying a by the inverse of the scalar. So in our particular example, right, this would be the same as saying 1/3 times the matrix, our same matrix, of 1, 7, 4, 3, 5, 6, right? Hopefully you understood the step to go from here to here. All we did was we took the inverse of the scalar, okay? Hopefully that makes sense. So now that we've done that, we do the exact same thing we did before. But this time, we're going to be multiplying by a fraction instead of a number greater than 1. It doesn't change anything. So we're going to still have our 3 by 2 output. I'm going to give myself plenty of room here. And then we're going to have our final result still being a 3 by 2 output. Okay, so what we're going to do is we're going to, again, copy our values from A. So 1, 7, 4, 3, 5, and 6. We're doing multiplication, so we're going to keep that there. And we're going to be multiplying. Again, we're going to move our scalar in to multiply all the elements by the scalar. 1/3, 1/3, 1/3, 1/3, 1/3, and 1/3. I know it gets a little cramped. So then we're going to multiply them through. 1 times a third is a third. 3 times a third is 1. 7 times a third is going to be 7 over 3. 5 times a third is going to be 5 over 3. 4 times a third is going to be 4 over 3. And 6 times a third is going to be 2. Okay, so that's how you multiply, well, that's how you divide by a scalar. You just multiply by its inverse. Hopefully that makes sense. Okay, so hopefully that made sense because we're going to look at another example. So in this example, we have a new scalar, which we've called L, and we're setting that equal to a half. And then we have a new vector we called B, which is going to be equal to a 2 by 3, right? 2 rows, 3 columns, a 2 by 3 matrix that has all of these even numbers in it. So the first question, what is I times B? So again, what I like to do is we're going to use blue to represent our scalar, and we're going to use red to represent our matrix. So our scalar is going to be 1/2 times our matrix, which is going to contain 2 rows and 3 columns. It's going to be 2, 4, 6, 8, 10, and 12. Right, and so if we do that, okay. So just like before, right, what does this equal? We're not changing our dimensions. This is going to be a 2 by 3 matrix just like before. So we're going to pull our values in 2, 4, 6, 8, 10, 12. We're doing multiplication, so we're going to multiply everything. We're going to multiply everything by our scalar. 1/2, 1/2, 1/2, 1/2, 1/2, and 1/2. Okay. And so if we follow through on the math there, right, we should get 2 times 1/2 is 1. 4 times 1/2 should be 2. 6 times 1/2 should be 3. 8 times 1/2 should be 4. 10 times 1/2 should be 5. And 12 times 1/2 should be 6. Okay. So this right here, this is our scalar multiplication. So let's look at what would happen if we divided, right? If we divided the matrix B by the scalar L, what would happen? Well, we have to go back and think to the same way we did before, where dividing by a scalar is the same as multiplying by its inverse, right? Multiply by inverse, right? We saw this in the previous example. So the way this is going to work, right? So now we're going to multiply by the inverse. So our scalar, the inverse of our scalar is going to be 2. Okay, and our matrix is going to be the same. So we're going to have that 2, 4, 6, 8, 10, 12. Okay, our matrix did not change. So what do we get? Well, again, right, we're going to end up with the same 2 by 3 output that we had as the input. So we're going to transfer our values from B. So this is going to be 2, 4, 6, 8, 10, 12. Because we're doing multiplication, we carry over that little sign there. Right. So, and then we bring in our scalar, which is going to be 2, because again, dividing is the same as multiplying by the inverse. So we're going to bring our 2, our 2, our 2, our 2, our 2, and our 2. Okay, so now we execute the arithmetic. 2 times 2 is 4. 2 times 4 is 8. 2 times 6 is 12. Right, 2 times 8 is 16. 2 times 10 is 20. And 2 times 12 is 24. Right, so this right here is the value you get when you divide by this fractional scalar. So hopefully that makes sense. Again, between these two examples, hopefully you see how this works on different size matrices and what happens when you multiply and when you divide relative to when your scalar is greater than or less than 1. So hopefully this all makes sense, and if you have any questions, please reach out. Thank you.